This video is going to cover the topic of writing algebraic rules. Be sure the date and topic are at the top of your page. The essential question for this video is, how do we write a rule that matches a given situation? In the past, we have talked about writing expressions. Remember that expressions are when we see numbers and variables together and with mathematical operations, but there's no equal sign. So an example might be x plus 6, right? That could be an expression. And mathematical expressions often represent a true situation. Maybe seeing x plus 6, you can think of an expression that would match this yourself. I thought of something like Nika is X years old, right? Some years old, and her sister is 6 years older, right? And that matches the situation because we know Nika is some age, but we don't know. So we use a variable of X, right, for her age. And we know that her sister is 6 years older, so we added 6 to it, right? So it becomes X plus 6. Expressions are helpful to write when we're presented with a situation that requires us to kind of look for a missing value. And translating situations into expressions can help us process and determine those missing values. So this is a really helpful tool for us to be able to see a situation and write it as an expression. And we use this same process for writing what we call algebraic rules. What's different about algebraic rules is that it's an expression, but it relates to variables. So it might look something like this, x plus 6, but then that equals a different value that we might call y. And it's not quite an equation, right? We're not solving for x, but it tells us what we could figure out, that we could figure out what y would be if we know different values of x. So with our Nika example, right, we can still see some similarities. We still know that Nika's sister would be X years old, Nika would be X years old, but this time we say that her sister's age is using the letter Y. And we know that her sister you could figure out her sister's age if we added 6 to Nika's age. So now we would say, okay, right, Nika's age plus 6 would equal her sister's age. And these rules are useful because we can use them when the information changes. So this rule would work if we know that Nika is 10 or we know that Nika is 42. Either way, the rule helps us organize our thinking. We are going to practice writing a few rules from situations, and we want to be sure we write the situations down in addition to the equations we write. Otherwise, they won't be super useful in the future. So be sure you're writing everything down that we do on the next few slides. To help us with this process, we're actually going to do some symbols that identify different parts that we need to write our rule. So when we are reading our situations, we're going to be underlining anything that is like the starting variable. So in this case from before, it would be Nika's age, right? We were starting with Nika's age. We're going to circle any value that's showing us that we are multiplying or getting a rate. We are going to box any value that's being added on. So like Nika's age, we added on 6 to that. And we will double underline anything that was a result of that process. So that might be like Nika's sister's age, right? That would be the double underline, the result. We'll try with another age question to start, or an example. So Tom's brother is 3 years older than Tom. So I know that I'm starting with Tom's age, right? And if I add 3 years to Tom's age, I'll figure out how old his brother is, right? So that's what our result will be. So now I'm just going to create some variables here. So maybe T for Tom. If I add 3 years to his age, I'll figure out maybe B for brother, how old his brother is. Right? So I took that information and I turned it into a rule, an algebraic rule that anytime we know Tom's age, if we add 3 to it, we'll figure out his brother's age. This one's a little different, and I actually included a question here to help us guide our thinking. But it says, Miss Sherman walks a distance of 4 miles every hour. What distance will she walk after 8 hours? So in this one, we know that we're starting with trying to know how far she can go after a certain number of hours. So our certain number of hours is what we would start with. And this time, she's doing 4 miles every hour. This is a multiplier, right? Every hour she walks, it's another 4 miles, 4 miles, 4 miles, 4 miles, right? That's a rate, a multiplier. And what we're trying to figure out is the distance. I'm actually going to underline distance twice, right? That's the result. We're trying to figure out how far she would go. So for this one, I could say we know that she's going to walk some hours. She's going to walk 4 miles each time. So I'm going to use the coefficient and say 4 every hour. And that would tell us the distance that she would walk. So this would be the rule I would write. 4 times the number of hours would tell us how much distance, right? And so if she walked 8 hours or 14 hours, we'd be able to figure out how far she went. In the next scenario, we see the science club is selling tickets for $5 each, and we want to know how much money they will earn if they sell some number of tickets, right? We don't know what that number would be, but we'll use this rule to write this out. So we know that they're selling some tickets. I'm going to underline my N. That's what I would be starting with, some number of tickets. I know each ticket is costing $5. So if I see this word each, maybe I'll add that up here. If I see something about each, this might help us to know that that's a multiplier. So it's $5 per ticket. And we're trying to figure out how much money they would earn. So I'm going to double underline that M for money. So I'd say we're going to sell some tickets. That was our N. We know they're $5 each. So I'm going to write $5 times N, or 5N. And that will tell us how much money they earn. And so if they sell 40 tickets, I could do 5 times 40. If they sell 80 tickets, I could do 5 times 80. And that would tell me how much money they have earned. And our last example that we're doing together has Tatum writing her novel, and she wrote 10 pages more the second day than she did the first. And we want to create a rule to show how many pages she wrote on the second day. So I know that we're starting with her first day. So I'm going to go ahead and underline that once, right? We're starting with her first day. And then she's doing 10 pages more. And that means something is being added or subtracted. So I'm going to make a little box around 10 pages more on the second day. And we are trying to figure out what that would be on her second day. So we could underline the second day. Of course, this also, I used the letter P to say I want that to mean the second day. So that's kind of in that writing already. So we know that she started with her first day, maybe F for first. She then did 10 more, and that told her how much she did on her second day, how many pages she did. So if she wrote 20, we could figure it out. If she wrote 42, we could figure it out. This rule would work no matter what. And now it's your turn. So there are two situations that I've recorded, and I'd like you to record these and use your underlining skills and your circling and your boxing, and go ahead and write the 2 rules that would match these 2 situations. And remember that the essential question of this video was, how do we write a rule that matches a given situation? So this is your chance to practice that for yourself. Bring any questions you might have to class, and we'll be sure to go over these together.